CSI Drivers stands for Container Storage Interface Drivers. It is a standard set of software components that allows storage systems to integrate directly with container orchestration platforms without needing custom code. It simplifies how storage is managed in container environments. Container Storage Interface, or CSI, is a common application programming interface specification. It enables storage providers to offer their services so that container orchestrators like Kubernetes can provision and manage storage volumes seamlessly, regardless of the underlying storage technology. The architecture of CSI includes key components such as CSI Drivers, which have node and controller parts, a control plane that manages storage operations, the container orchestrator like Kubernetes, which interacts with the CSI, and the storage backend systems that provide the actual storage resources. CSI is made up of components called node drivers and controller drivers. The node driver manages volume operations like attaching, detaching, mounting, and unmounting storage on cluster nodes. The controller driver handles important storage lifecycle tasks like creating volumes, taking snapshots, and deleting them. Sometimes there are external controllers that run separately for managing storage tasks. All of these components communicate through standardized application programming interfaces. CSI allows Kubernetes to manage storage dynamically without embedding vendor-specific code into Kubernetes itself. Kubernetes uses CSI drivers to request storage provisioning, attach storage to nodes, mount volumes into containers, and manage the storage lifecycle across multiple storage backends efficiently. Storage providers develop CSI drivers based on the CSI specification. They implement node plugins to operate directly on Kubernetes nodes and controller plugins to manage provisioning, snapshotting, and volume attachment. It is essential for these drivers to stay compatible with the CSI standards and Kubernetes versions to function properly. CSI supports several important features, including dynamic provisioning of storage volumes, attaching and detaching volumes across different nodes, supporting snapshotting for backups, working with multiple types of storage backends, monitoring the health of volumes, and expanding or resizing volumes when needed. To use CSI drivers, install them into Kubernetes clusters, usually as daemon sets or stateful sets. Storage is requested by creating persistent volume claims, which the CSI drivers use to provision and manage. Kubernetes and the CSI drivers handle the full volume lifecycle automatically, including attaching, mounting, resizing, and detaching. Monitoring and troubleshooting are done using Kubernetes tools like event logs and metrics. Popular CSI drivers include OpenEBS local persistent volumes, Portworx by Pure Storage, Ceph RBD, and Ceph FS drivers, vSphere CSI driver for VMware environments, Amazon Elastic Block Store CSI driver, and Google Cloud Persistent Disk CSI driver. These drivers support different storage technologies and cloud platforms. Regularly, check the logs of CSI drivers for any errors or warnings to catch issues early. Always verify that the CSI drivers are compatible with the version of Kubernetes you are using. Use health probes and monitoring tools to track the status of volumes. Keep drivers updated for new features and security fixes. Periodic testing of storage failover and recovery ensures reliability. CSI offers advantages like being vendor-neutral and extensible, which improves the Kubernetes storage ecosystem. However, not all storage features are supported by every driver. The use of external controller drivers adds complexity. Staying current with Kubernetes versions requires regular updates to CSI drivers. CSI drivers provide a standardized way to integrate storage solutions with Kubernetes and other container orchestrators. To learn more, consult the official CSI documentation, explore topics on GitHub repositories, and participate in community forums to deepen your understanding and contribute to the ecosystem.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.